Fire in the hole. Welcome to Fro-Dog Arcade Repair, and welcome to Sanwa-a-thon 2026. I'm going to go through 7 Sanwa chassis. They are the PM1745C, or also known as 27Z21C Sanwa chassis. Now, I have already done a sink wash and dry on all 7 chassis to get them nice and clean. This started with a customer who had a Time Crisis 3 who had 2 Sanwa monitors. One had no red, both had just some diminished performance, time for some maintenance, some reflow. I'm going to do cap kits at the customer's request, as well as I think they need done for best performance. But the primary reason that we started with the monitors is one had no red. And the no red actually turned out to be the CRT itself. And the red gun just wasn't firing. I did get out the Sencor CR168 Big Mac CRT analyzer, did a little rejuvenation on it, got the red gun firing correctly again, let it burn for, I don't know, 2-3 hours, and the red started fading. So I went to a little higher rejuvenation on rejuvenation 2. It seems to be sticking for now. But I'm going to go ahead and go through the chassis themselves. I'm not all that familiar with this chassis. Quite frankly, the first of this particular model I've worked on. But both chassis from the customer, fully functional, and after washing and drying, I just wanted to get it back on a tube and see and prove out that it was working. I do see the red looks a little high. I'm sure the pots got disturbed a little bit while I was cleaning them and going through it. But here it is, lit up, functioning, and we're going to get it on the bench. We're going to do a cap kit. We're going to do some reflow, and then fine tune it on the monitor. And ultimately, I want to color match these 2 monitors, since in a Time Crisis 3, they sit next to each other and will look best matched. So here we go. This is the first one, and let's get it to the bench. On our way through the shop to the workbench, here is the row of freshly cleaned Sanwa PM1745s. I've got the bottom frames off of them. They have all been washed clean. You can watch another video I have up that shows how I clean them. Simple green in a sink, hot water, and then dry them out with fans. First I blow all the water off with an air compressor. Then I dry them out with my Ryobi fans and a box fan. These particular chassis have been drying out for 2 days now. So, onto the bench. All right, here we have it on the bench. I haven't really gone over this board beyond just making sure that it was functional. It started functional. Let's start by getting the remote board off and out of the way. Actually, I think these unplugged from the main PC board. So let's do that, and we'll get the whole wire harness gone. Yep, hand plug right here. Alright, so we got our remote board out of the way. Before we do that, let's just take a quick inspection of our remote board. I don't see any solder joints that look funky. Pots look good. Nothing looks cracked. Alright, I think our remote board's good to go. Let's get it off to the side. Now, let's take a look at our CRT neck board. Take a look. Things look pretty good here. I see a little bit of solder touch-up we can do, and then we'll clean some flux off. But overall, looks pretty good. Our component's pretty straight. I'm a big proponent of straightening up components and just making it look correct and right, that the resistors aren't all smashed over, that they look like they belong. This particular one looks like maybe the factory didn't get it quite down in the hole enough. But yeah, not much to do on the neck board. Let's take a look at our main chassis here. Well, first thing I see is we can cut these zip tie leaders off. Get that out of the way. This looks like it's going to be a little bit of a challenge getting down into the caps where the flyback are, down in this cage. I see a little piece of something right here. I think that was perhaps part of a clip of that nature. And those clips are brittle and broken, so we'll have to address that. Probably with some zip tie and tie pad action. Let's go ahead and take what's left of those off. Okay. I think that is just a rubber spacer block. Definitely not a component. So top of our board, straighten up a couple of components. Straighten our pots up a little bit. Overall, everything looks good. Now what I am noticing is, like on this cap and some of the others, they've got a black mark on them. Now I do not think this board has been recapped. The reason I say that is if you look down in here, you can see the glue from the factory holding those caps. So those marks had to be something that went along with the factory installation or some sort of QC project. Looks like we can take some screws out here and get our cage off of the flyback. Let's look. Got a lug there that can be unsoldered. There's some flux on the bottom here, but it looks factory to me. This doesn't look really as much reflowed and touched up as one might think. It might be on these pin headers here a little bit. But overall, I think this is a pretty virgin chassis. Hasn't had anybody in it. I don't see any breaks, cracks, anything like that. All right. What else can we do? Oh, you know, I think the simplest solution to get into that flyback area for those caps is going to just be remove the flyback. Let's start with getting some solder out of the way. Yeah, I think maybe my desolder tool went to sleep on me. So we'll let that warm back up. In the meantime, get to the old trusty Weller and some solder wick. I do see is there is a metal press-in lug in the board for each one of these. That's going to make it a little tougher to remove. In that case, I think I'm going to reflow some solder around that so that our solder sucker has something to work with. Maybe hit all these pins so that solder isn't so old and crusty. Now, some of the things we're going to do with the cap kit is show you what I like to do on replacing caps. I am not a cap crusader. I don't believe that caps fix everything. And search for root cause failure first, and then utilize a cap kit as far as maintenance. That was our solder tool telling us it was done and ready to go. Let's see what we can do with that. I suppose it must be plugged up, as usual. I can say that these are great when they work, but they're high maintenance. Alright, we're going to go old school here with the old solder pult. The desolder tool is a little more plugged up than I want to fight right now. Alright, you probably don't want to see me do solder sucking all day long and trying to get flybacks out of the board. So I'll come back when I'm ready to do the cap kit, and I'll show you my process for marking caps and just how I get through it. Alright, we've got our flyback out of the way now. That opens up a lot of space down in here for us. Let's push the chassis off to the side, and let's open up our cap kit from Arcade Parts and Repair. I'm going to go with the ones on the strips together are the same values. Fair amount of individuals. And of course we have quality Nichicon caps from Arcade Parts and Repair. You know, they may cost a little bit more than some other folks' cap kits, or, you know, I've heard guys say, oh, I can, you know, build that cap kit for less money than that. Yeah, but what's your time worth? You know, sourcing these parts, hunting them up, and ordering them all individual from somebody, and trying to get them all in and get them into one pile. Time value of money is definitely something to consider. So Arcade Parts and Repair also includes a nice little instruction sheet to go with your caps. And we got a PM1745 27Z21C color monitors. 2 names. And then kind enough to list the cap locations and what value goes in each. Got one that's located on the neck PCB. There's another note, C441 and 811 have different capacitor values on the chassis. So make sure to install the same value that you removed originally from your chassis. Alright, so what I like to do is replace one cap at a time. I take a good look at my board. Here, CRT neck board. We've got one capacitor right here on the corner. We can see the designation here at C909 like our instruction sheet says. Now, if you notice on the board, they will often be indicated, like here's a little plus sign for this one, and shows us the positive lead. Now, don't blindly pull all your caps and think that the board's going to guide you to get them back in correctly. There are more occasions than you might think of boards just being silk screened wrong. They have a positive and a negative indicator that is incorrect. So always double check your caps to make sure that the correct unit goes in at the correct orientation. Again, we'll do a little component straightening there. Always hate to see neckboard resistors all bent over and crunched and funky looking. I've been called a perfectionist. I've been called a little anal retentive. I'll take both of those in this line of work. It's attention to detail is truly my favorite word for it. That attention to detail will help you out in the long run. That looks like it's soldered into our CRT socket good. We don't have an issue there. All right, so next step is get our trusty Ticonderoga pencil, and as we find each cap and replace it, we'll tick it off of our list. We'll confirm the value that is on the instruction sheet with the value physically on the new cap and the old cap. Now, rather than go through the sheet in an order that's listed, I tend to go to the board and do a section at a time, where, like, I'll start in the flyback cage, and we'll get the couple of capacitors down in here. Looks like we've got 4 of them, 4 electrolytics, and we'll get those units out, replaced, and marked and back in. So bear with me while I do the first couple of caps here, and then I'll do a little breakaway and come back with a completed capacitor job. Start with this one right here. Now, it might fight us a little because it's got glue on it. And our negative stripe is towards the cage. Our first unit out, the board is silk screened correctly. Let's get this little chunk of glue off the board. Throw that over in our cleanup scrap pile. Designator on the board is C110. And C110 is here. 1000 mic at 25 volt. 1000 mic at 25 volt, and we've got 1 in our kit, 1000 mic at 25 volt. So let's find it in our pile here. Thousand microfarad at 25 volts. All right, we'll get the tape off of it. Get a little wick, open the hole up. I find it's easier to pull them out with my fingers as I'm removing, and then wick the hole clean to get the new capacitor in. Just like that. 1000 mic, 25 volt. Okay, soldered in, and excess leads clipped off. Now, I have a little container on my bench that I throw the component legs into, because you never know when you need a component leg for a board repair. Now sitting down in there nice and tidy. Now I like to use a yellow paint pen to show that I've been to a cap. Let's go to our next one. And again, one at a time. You pull them all at the same time, and you don't know which cap came from where. Like the instructions indicate that if you've got one that might have two different versions of the chassis. This one came out positive or negative towards our heat sink, and the board is marked correctly, 50 at 220. But as I was saying, one at a time keeps you out of trouble. I have seen more trouble caused by amateurs doing cap kits, putting them in backwards, wrong values in the wrong place. I've even seen caps that are just gone. They were forgotten to be put back in as part of the replacement. Let's wick that hole clean while I'm thinking about it. Designator on the board for that one is C426. C426 is here. It's a 220 at 50 volt. And we've got 5 of those. So I'm going to put a hash mark out there that I've got the first one out. 220 at 50 is correct. There are 5. Look at that. There's a strip of 5. That makes sense to be 220 at 50 volt. I have actually pulled the legs out of a new cap before, trying to get them out of those glued on strips. Try not to reef on those too hard. Again, back here, our negative goes towards our heat sink and shield. Get one leg tacked, and then we'll reach up in and push it flush on the board. All right, get our other leg tacked. Component legs off. Capacitor number 2 down. Okay, I'm going to jump back in here. I just pulled out C811, which is a 33 microfarad at 50 volt. If we remember our note down here, C811 could be a 4.7 at 250 or a 33 at 50. Our board, and it says to replace with the same that comes out of your board, which a 33 at 50. Now, if we notice this particular capacitor, I don't know if you can see it well enough, but it is a 33 at 63. Now, that is not a problem. You can change voltage values up, but you should not change capacitance values down or up. So our 33 microfarad is the same, but our voltage, our working voltage, is 63 volts, which is slightly higher than the 50 that it was designed and spec'd with, and that is perfectly acceptable. All right, here's another good reason to not blindly pull all your caps. Not only was our last cap, C811, the special cap, that 33 at 50 came out on a different version of chassis, it could have had a 4.7 at 250. So we put the 33 at 50 back in. If we'd blindly pulled all the caps first, we wouldn't know which cap went where. The next cap I've come to is C424. 424, the physical cap that came out is 1 microfarad at 50 volts. And the kit documentation is calling for 1 microfarad at 250 volts. Now I wondered if that was a typo, so I counted how many 1 microfarad at 50 and 1 microfarad at 250 were in the cap list, and the parts list shows the correct quantities to include C424 as being at 250 volts. Now it is also right next to our big 100 microfarad at 250 volt units, and it does share a positive leg tie with one of those larger caps. So I am going to, even though the factory came out at the 50 volt, I'm going to roll with the 250 as the cap kit instructions suggest, and it makes sense to me in the circuit based on the other voltages. All right, we've completed the cap kit. Wanted to point out a couple of noteworthy things that I found. One is we should have 2 leftover caps because of putting in the value that was in the board, and that would have been C441 and C811, because the cap kit provided for both of those possibilities, and new instructions are replaced with what's in the board. So we do have 2 leftovers there. We have 1 leftover, which is C113. Let's see if I can bring this over. C113 is 100 mic at 50 volt, but there is no C113 I can find on the board. Now I find here these tantalum caps right by this wafer IC is C114, 115, and 116. So 113 should be in this same supply circuit, and it's not. I don't find a silkscreen spot on the board for it either. Now, in reference to 114, 15, and 16, we have electrolytics that came in the kit that are 3.3 volts, 3.3 microfarads at 50 volts. But since they're not electrolytics and they're tantalums, I'm going to leave them alone and not replace them with a different style of cap. So all told, that leaves us with 6 leftover caps that the kit provided for, but did not need replaced or weren't specific to this subset of the chassis. Another interesting point is this transistor here, Q403. It was sitting at a little bit of a funny angle. I looked to straighten it up and it was loose. I looked and all 3 solder connections were all ringed and very, very light. I would suspect on these Sanwa chassis, this PM1745C, or also known as a 27Z21C, that this would be a high failure point for bad solder connections. I also reflowed all pin headers. Here, I reflowed the 2 wafer ICs. Specifically on the pin headers, I did find some ring solder joints on pin headers. Solder joints on those were really globbed up. They had a ton of extra solder on them. So reflow is not always just about adding solder and touching up a joint that is sketchy. It can also be getting rid of globs and donuts. I've seen on rework chassis where K7000 from Wells Gardner comes to mind, where there's a the horizontal horizontal width coil gets pretty warm, and the legs on it can get kind of cooked, and they don't want to wet well with the solder. And the best thing to do is go ahead and pull it out of the circuit, burnish the legs up with a little fiberglass pen brush. I've got a couple of variants. This is the spot sanding pen that you find in the auto parts department at some auto parts stores. You can order them on Amazon as well. And I've got another variant around here somewhere that is more the Amazon special, kind of like, it's a Chinese knockoff, but it is a nice little fiberglass sanding pen. Either's fine, but you need to burnish those coil legs up and get some fresh solder with good flux to stick to it, versus I've seen where, like take a pin like here and it will donut around it, but not wet to the pin and make a nice little volcano shape for you. The other thing that I was going to do is, this chassis is not as old as some of the units out there. When you get into like G07s that are from 1981, I like to replace the filter caps in those a little more often, where some of this stuff that is 20 years old instead of 40 years old, I'll take the filter cap out and test it. I've got a handy little capacitance checker here, and let's see what it says. 625.12.1 microfarads, and if we notice, our ESR is 0.12 ohms. So it's got a nice low ESR. It's well within spec. It's a 680 microfarad at 200 volt capacitor. This filter cap looks good. Sometimes they have, like this one has the little extra plastic cap on the top, and you'll find that sometimes those, with heat and time will look a little more domed, but if you push on them, you can feel them give underneath. The capacitor's not actually exploded out or bulging. It's just the way the plastic is on it. And this particular cap, like I said, is 680 at 200 and tests out great, looks good, and is a younger cap than, say, some of the older gen chassis. So I'm going to put that back in and not replace the filter cap. One other noteworthy thing on the Sanwa chassis here is I did not find a single silk screened indicator on the board. Every silk screening for the caps were all polarity correct. There were no errors or backwards, which is actually pretty unusual. But that's what we have. So I'm going to go ahead and put this filter cap back in, and then I'm going to clean up all of our flux and goo all over the board here and make it look nice and minty fresh. I touched up a few other high points. The transformers in the switching power supply sections, those work at a high frequency and they actually vibrate a little bit. So I like to touch up those transformer legs as a matter of course. Look for any high heat components. If there's any discoloration, that's a great place to go look for bad solder joints. Your higher wattage resistors, which reminds me, I've got to put this back in. This particular ceramic resistor from here on the corner of the board was all kind of bent and tweaked over, so I pulled it out of circuit, straightened the legs. I'll get that soldered back in, and like I said, we'll get her soldered together. I need to make an insulator for the back of the CRT neck board. It did not have an insulator with it, so I'll either find something or make something. Oftentimes even a piece of poster board, cardboard. Some of them that come from the factory are thin plastic, but I do believe in putting the insulators back on there and making it like it should be. So that's what we have as I wrap this up. I still have to put our flyback back in. I'm really glad that I took that out. It gained much easier access to the caps in that area, as well as it took all that weight off the board as I was flipping it back and forth, 40 some times doing the various caps. So I feel that was a good decision as well. Your mileage may vary. So there we have it. Sanwa number 1 is recapped. We'll get our metal frame back on it. I've got the frame here. I took it off for ease of use and to see all of the solder connections. we'll do our little bit of reassembly work here and put it on a tube. All right, I made a little change in plan. Decided I would show you how I clean the flux off of boards and pretty them up. We'll start here with the neck board, and what I have is a squirt bottle that I keep denatured alcohol in. Now, I like denatured versus isopropyl. Isopropyl, it dries fast and all that good stuff, but it is not as solvent capable as denatured. So I like to use denatured. Just wet the back of the board down a little bit. And we go after where we've touched up solder joints, as I reflowed all 3 color transistors here, as well as the heavy resistors that get heat soaked. The CRT socket looked good, so I didn't go after it with the soldering iron. Again, it's not about hitting every joint. It's a little more towards hitting suspect joints, joints that don't look decent and shiny, where you can physically see the cracks along the bottom. Got to go with the grain on these transistor pins to clean up good between them. Let's do a little final rinse. Kind of blot dry a little bit. Let's look at our other side. All right. Now we have a clean board that doesn't look like a third grader has been snotting all over it with flux up to our elbows. I'm going to do the same thing on the main chassis here. Now, if you notice, we have quite a bit more solder work on here. A little bit factory, a little bit of what I did on reflowing, and we have all of our components back in. I mentioned this sand block resistor here that I straightened up and put in like I thought it looked correct. Got our B+ cap back in, got our flyback back in, and don't forget your screw in the flyback. A lot of them have a screw in the edge of them here. So I'm going to clean the main board here, and we'll show it to you when it's all done, and then we'll light it off on the chassis. Okay, one more time before we go over to the tube to light it up. Here's the cleaned board. Notice not a bunch of flux everywhere. You can't tell every joint I've touched, every component I've been to. And it's nice and clean and ready to go. I do see one little area of flux that I don't like the looks of. No. Clean that up just a little bit more. There we go. All right. Let's get the frame on it. Let's get it to the tube. Here we are back, reassembled in the CRT and frame. Make sure we've got our high voltage anode connected. We've got our ground wire on our neck board. Our power wire wraps around back into here. Both are connected. We've got our degauss coil connected. Yoke is connected to the normal position. These will not fire up unless the remote board is connected. Ask me how I know. That was from earlier experimentation. So I think we are ready. We've got our test pattern generator. I've custom made a plug out of the 12-pin Molex that fits this. It's got power, red, green, blue, ground, and sync in it. I just put a 2-pin Molex so it goes to my regular power cord over here to the fire and the hole switch. So without further ado, let's see what happens. Fire in the hole. Ooh, I hear a little bit of static. Sounds like it came up. Let's look. Jackpot. We have image. Looks pretty close to what it did before. A little bit of degaussing down in that right corner, a little bit of purity going on. But not too bad. And you ask, what are the big L and R in done in masking tape on the front? These two units are from the customer's time crisis machine, and one is the left monitor and one is the right monitor. So I wanted to keep them straight when I pulled them out because I knew one had a red issue. Like I said, I did a tube rejuvenation on this. Let's see how that checkerboard looks. A little green. Red is present. We have all of our colors. Color bars look pretty decent. Can use some fine tuning. Red, green, and blue all present. There, that purity down in the right corner really sticks out, but I think good pass the degausser will take care of that. As well as soon as I move it back to the customer's house, it'll be sitting in a different environment. Need degaussed again, I'm sure. Red, green, blue, and white. Yeah, not too bad for just a straight up cap kit and ready to roll. All right, I'm going to call that a win. And Sanwa number 1 is done. Thanks again for tuning in for the Sanwa chassis repairs. I would ask that you follow the channel, hit that subscribe and like button, and join us for the next batch. I'm going to dive into Sanwa chassis number 2.